All right, let's look at the homework 11, problem number 6. All right, so we want to just multiply this out to show that M is a symmetric matrix. Right, so let's do that. So M is going to be, right, C is given, so you just have C, which is cosine of theta minus sine of theta, right? Sine of theta, cosine of theta, right? So this is simply a rotation matrix, and the D is the diagonal matrix. So you just have lambda 1 and lambda 2, 0, 0, right? The C inverse matrix would be, since this is a rotation, so it's going to be a rotation by theta clockwise, so it goes the other direction. So that's going to be simply cosine of negative theta is same thing as cosine of theta. Sine of negative theta would be same thing as negative sine of theta, so it's going to be sine of theta, right? Sine of negative theta is negative sine theta. Alright, cosine of negative theta is the same as cosine of theta because cosine is an even function. Alright, so we just have to multiply out. So this is going to be equal to, right, this times that gives you, right, lambda 1 cosine of theta, right? This times that gives you negative lambda 2 sine of theta. Right, this times that gives you lambda 1 sine of theta. Right, this times that gives you lambda 2 cosine of theta. Right, then the next one is cosine of theta, sine of theta, negative sine of theta, and the cosine of theta. Alright, then this is going to be equal to, right, so, right, this times that gives you lambda 1 cosine squared plus lambda 2 sine squared of theta, right? And this times that gives you lambda 1 sine theta cosine theta minus lambda 2 sine theta cosine theta. Alright, and then this times that gives you lambda 1 sine theta cosine theta minus lambda 2 sine theta cosine theta, right? And this times that gives you lambda 1 sine squared of theta plus lambda 2 cosine squared of theta, right? So you can see that you have a diagonal, and here this element is exactly the same thing as the original one, so therefore this is exactly the same thing as, right? And if you take the transpose, right, so if you write it this way, you know, all the rows as columns, you're still going to get the same matrix, so therefore this is a symmetric matrix, right? That's it. I hope that this was clear.